In this video, I want to talk about dimensioning the views of the offset flange. So in this project, we're only going to show two views, a front view and a right side view, because we don't need the top view to describe this object here. So I've already placed my views, and I'm going to start by placing some dimensions over here on the right side. And let me click on this, and I want to quickly show you what I'm going to be focusing in on here. I apologize. Here we go. All right, so on this one we have 5 holes, and we have a tolerance of position on those holes. And the things that affect the tolerance of position are this radius right here, which has a radius of 75 and is shown as a basic dimension, so we'll have to show it as a basic dimension. And then there are 4 45-degree spaces that we have that also define these locations of these 5 holes, and the 45 degree is also shown as a basic dimension. And then we have this diameter over here of 200, and attached to the leader we have a datum ID that says B. And so when we come up here and we look at our tolerance of position, what it is telling us is to position 5 diameter 19 holes, and that the center axis of those holes should run through a 0.35 millimeter cylindrical tolerance zone when this hole is at maximum material condition, which would mean when that hole is made at its smallest diameter, relative to datum planes A and B. Now A is coming in on the back side of the part, so that would mean that we would have a inspection plane in the back that we would put this part up against, and that would represent A. So really what's happening here is that the cylindrical tolerance zones should be perfectly perpendicular to A, and then those cylindrical tolerance zones are located relative to B, and here we see B, and what B is it's the center axis of this cylinder right here. So measuring from the center axis of this cylinder, we come out a basic 75 millimeters to find that arc right there. And then we also, relative to where the center axis is, we have 4 perfectly 45-degree angles. And what that does is locate the 0.35 cylindrical tolerance zone. And the center axis of all of these diameter 19 holes needs to run right down through the center or stay within that 0.35 millimeter cylindrical tolerance zone. We also have a flatness GD&T applied to the back, to this back surface back here, and you'll notice there's no reference plane on that. So, it's just either the back is flat within 0.12 millimeters or it isn't. Then this front plane that we have right here should be parallel to datum A, which remember would be like a surface plate in the back, within 0.12 millimeters. All the rest of the dimensions on here are just standard location or size dimensions, so we don't have to worry too much about how we put those on. We just follow our normal rules. Okay, so let's get started. So we're going to start by putting that 200 millimeter diameter dimension in, and so we look over here, we see that cylinder right here, but if we're following the ASME Y14.5 rules, we're going to place a dimension, and we're actually going to pick at this corner, and we're going to move out in this direction here. Okay, now for some reason my text is running vertically, so I'm going to press escape, and I'm going to try to figure this out. I'm going to go to edit dimension style and see if I can find out what's going on. So take a second for the dimension style to open. All right, so let me see here, alternate units, display. One of my settings here I have is vertical dimension incline. I think that's the one that I need to fix on this one. So I'm going to go back. What I want is that right there, and pick save and close. And there we go. Now I also don't want these trailing zeros because I'm using the metric system. So I'm going to go edit dimension style. And again, it takes a second to open up. I'm going to turn those off. I do want leading zeros though on anything that's less than 1 millimeter. So let me see if there's anything else I see in here just real quickly. I don't think so right now. So I'm just going to go ahead and pick save and close. Now on this one, I need this to be a diameter of 200. So I'm going to double click on that. And what I want to do is come over here to text and put my cursor in front and then choose the diameter symbol like that and pick OK. Now, the center axis of this diameter 20 is actually the datum B. And so here's how I'm going to place that in there. I'm going to come up here to my datum identifier symbol. And I'm going to pick on this line right here and pick, and right here I'm going to change that to capital B and pick OK. Now then I'm going to press escape, get out of that. I'm going to straighten that like this. I'm going to drag it down a little bit, and here's the important thing that I have to do. I have to drag this, and I want to line it up exactly with my diameter 200 dimension. And when I do that, I'm implying that it's the center axis of this dimension right here that is datum B. Okay. Now I know I'm going to have to move this out farther than what I have right now. Normally I would just place it like right there and make sure that my datum identifier stays lined up perfectly on that. The reason I know I'm going to have to put it out farther is that I'm going to have to place a feature control frame symbol on this. And so if I pick here and I move and I pick and I right click and I choose continue, what I need this to say is I want flatness, and I want this to say 0.12. It may put an extra 0 in front of there, but I don't want A or B in there. So I'm going to pick OK, and let's see what I get. I'll press escape. So I'm going to double click on that. Even though I put the 0 in there, it looks like it's suppressing the leading 0 on this. So I think I've got a setting I need to go in and change. So I'm going to go to Edit Feature Control Frame Style. And it'll take a second for that to open, because what I want is for my leading zeros to show. So I'm going to pick on this. I want leading zeros to show, but I don't want trailing zeros. And I'm going to save and close. So that's what I want that one to look like. So the thing is, I do not want this leader to cross my diameter 200. So I'm going to have to drag my diameter 200 out here. And then I'm going to actually move this in a little bit. Now, one thing I didn't show you is that when you place your datum ID symbol, you can actually snap right to the end point of that arrow, and generally that will lock it into place. And when you move it, everything stays exactly where that's supposed to be. All right, so the next dimension I'm going to put in here real quick is the width of this. So I'm going to come up and let that snap like that. I'm going to do another dimension between these 2 points here, and I want to line those up. So if I come over here and I kind of park that, you can see I get like a polar tracking line, and I can just pick right there. I would force this 25.4 inside, but I don't think there's going to be enough room to put that in there. So I can go to dimension, go from this corner to this corner, come straight up, and I'm going to let that snap like that. So I want that to be 100. And so at this point, I would take my highlighter, and what I would do is I would go through and I would highlight the 100 that I have right here, and the 25 here, and the 25 here, and the 200 and the B, and also this flatness symbol on that. So I want to be highlighting you know, as I work my way through here. Okay. So I'm highlighting all those things. And so the next thing I want to do is come right down here, and I need to put a datum identifier on this, and I'm going to move out here, and this is actually datum A, and I'm going to pick OK. And it's okay to put it on this edge like that, or if you prefer, you could even pull it off down here. You could even take it and move it up into here, but you don't want to line it up with the 100 if you do that. If you line it up with 100, actually what you would be indicating is that the datum A would be the midplane between these two sides of the 100. So it's important that we don't line this one up, even though we line this one up right here. Okay, so I've got my A on there. I just need a couple more dimensions on this. Let's see. I have another diameter right here, the diameter for this guy, that's 100. So I'm going to move this out in here somewhere. One of the things I want, you see the spacing that I have between these, I want to keep that same spacing. Actually, I have to. So what I want to do first off is put my cursor in front of that and put a diameter symbol in front. Okay. Now I can move that out a little bit. This is getting a little crowded in here, so in that case I would probably move that up, kind of offset those guys. And I'll come back in later and fine tune all of this. So I want another feature control frame. I'm going to put it here and come out in this direction and pick, continue. And this one I want to be parallel. And my tolerance is 0.012. And this is relative to A. And there's no B on it. So I'm going to back that off. So that's what that will look like. And pick OK and press escape and get out of that. Now I can bring that in a bit if I want to. I could bring it even down, but you know, you want to make sure that it's clear that there's some space between around this arrow right here. And if I wanted to kind of match the length and the angle of that, I could do that. And at that point, I might even move these two dimensions in a bit. Now over here in this view, I need center marks for all these holes that go through. And so you can use your center line bisector if you want. And for example, I can pick on this hidden line and this hidden line here. And I've got a hidden line here and one here. And hidden lines for holes over here. And then I have one right here in the center, and that's actually being covered up by this extension line. So I'm not going to worry about that. I would want one there, and I'd want one here. And I'm going to press escape. So the next thing I want to do, I want to make sure though that these extend out about 1/4 of an inch past the edge of the hole. And so these all look pretty good. So I'm going to let those go. Now let's look at what the setting is that I have for my center marks. I'm going to right click on those and go to Edit Center Mark Style. And let's see what comes up. So because this is a metric drawing, what I want the distance for A to be is about 2.5 millimeters. And I want the gap right here at B, I want that to be about 1 millimeter. And my overshoot, which is right out here, I'm going to set that to 6 millimeters. And I'm going to pick Save and Close. And you can see that it did change things. I may have to extend these guys out a little bit farther now because they were out. They were, you know, that setting was pushing those out a ways, and I may want to bring those out now. Let's see. One of the things that I know is, for example, the diameter of this hole right here in the front is 9, and so that gives me some idea of what 6 would look like. Okay. And so, you know, these might be a little bit long, in fact, right here. So I can bring those out just a little bit, maybe. Feels like a Bob Ross video at this point. Okay, so I still need to put a diameter from this corner to this corner and bring that out. You know, one of the things you can do is you don't actually have to pick on the corners, and there's an advantage to that with these cylinders, because Inventor's kind of smart. If you do a dimension, and instead of picking from corner to corner, if you pick on the edge and move it like that, it actually recognized that that is a diameter. And so I could have done that over here. I just want to point that out to you, that you can either pick on the corners and add your diameter symbol, or you can go ahead and actually do it that way. Okay. So anyway, and this one it might have had trouble figuring out. I think it would have gotten it because that line is collinear right there. All right, let's see. I may be missing a hole. I think there's a hole right in here too. I want to place a center line on right there and drag it out just a little bit on each side. So I hope that I got all those holes in there. I kind of want to move this video along. All right, so I need to put center marks in for this whole pattern here and for this whole pattern in here. And so we're going to use the center mark, or the centered pattern. We're going to pick on that, and once you pick on it, it says right over here on the bottom left, it says select the center of the centered pattern, circular pattern. You should pick on the 200 millimeter diameter cylinder. Pick there, then pick inside that hole, and pick inside this hole, and this hole, and this hole, and this hole, and at that point we're done. So we're going to right click and pick create. Now if you don't see these gaps around here, it could be that you have your center marks too large in the center mark settings. So in that case, you would right click on this, and first you have to press escape, and you would go edit center mark style and set those to the settings we had. But another reason why you might not see all your dashes is that you see this center line here is running through this hole. And so if I grab right here on this center mark and watch as I pull it back, you can see that that one was covering these gaps right here. And so now I want to drag this one out about 6 millimeters. I want to do the same thing over here, drag it all the way back so I can see 4 gaps right here, and drag this one out. And I've got the same thing going on right up here. I'm going to drag it back, and actually I'm going to have to put a center mark in here. So I'm going to drag that one all the way back. I'm going to bring this one out because it's on the y-axis and the x-axis. I'm bringing those out about 6 millimeters. Now this one in here, I'll probably also bring back, and you'll see why in just a second. Okay, so I want to put a center mark on these 5 holes here, so I'm going to use the pattern again. You would pick this 150 millimeter diameter cylinder, pick there, pick there, pick in the center there, pick there, and then come back to the first one and right click and pick create. Now I can see that I have gaps around all those marks, but this one now I've got something covering it up. I think it's this one. I'm going to have to pull it all the way back to there, and that allows me to see that. And then on this one, now it's coming all the way to there, and it's covering this guy. So what I want are 4 gaps around this. This is the true center of my entire thing. And then I want the gaps around these. So on this one, I want to pay attention to all of these gaps. And when I grade these, I definitely pay attention to all those gaps. So if you hand it in and your gaps are closed, like you don't have 4 gaps around each one, I'll be marking those in red. All right. So now what we want to do is, depending on how you created this hole, if you used a hole, the hole tool to do it, you would pick on this and pick and come out here like that. Some students will draw a circle and do an extrude cut with a circle, and we don't need that. Now on this one, this was modeled through all, so we don't need to have this diameter or this depth of 0.25, 0.4. So we can come over here and delete that out of our note and pick OK like that. And but one thing we do need to add is in front of this, we want to say 5 and a capital X and a space, and then pick OK. So we're going to have a 5X, and now we need to come in here and place a feature control frame. So I'm just going to pick and immediately right click and pick continue. And I can drag that over here in just a second. So I want to choose tolerance of position, And then I want to put in a diameter symbol. And then I need a 0.35, and I believe it's going to add a 0 in there for me because I have leading zeros on. And following that, I want to add a maximum material condition symbol. And then I want A and I want B. I do not need a C on this. I just A and B and pick OK. And then press Escape. Now come up here and grab that dot and just drag this over to the side. So let's check it. It says 5 times diameter 19, tolerance of position at a diameter of 0.35, maximum material condition A and B. That looks good. All right. Now the next thing I'm going to place in here is going to be a dimension. And I'm going to pick on this line here, and I'm going to pick on this line here, and I'm going to drag out in this direction right there. And then I'm going to also do a dimension here where I pick on this arc. And I'm going to drag and put it out approximately right up in here. And then I'm going to do a dimension where I'm going to pick on this line, and I'm going to pick on this line, and I'm going to drag those out to about right there. And then I want to put a hole node in, again, like right in here, and I'm going to double click on that guy and take out the depth because it goes all the way through that first flange. And I need a dimension from this point to this point right in here. I'm going to line that up with the end of my 45 degrees. And one of the last things I need is a hole node for this counterbore hole, which goes right in here. Okay. Now on this one, I need this to be a reference dimension, and I need it, I'm sorry, a basic dimension, and I need it to say 4x. So I'm going to double click on that, and I'm going to go to precision and tolerance, and I want it to be basic, and I don't want that 1 decimal place that it's showing right here, the 45.0. So I'm going to pick on angular units and pick 0 and pick OK, like that. All right, now I'm going to double click on that again and go to text. And I'm going to move my cursor in front of it. I'm going to type 4x and a space and pick OK. And so it put the 4x inside the box. So I want to deal with that. I don't want that to be in the box. And that's actually called a prefix. And so there's a way to force the prefix outside of your basic box here. And so we're going to do that. We're right click on this and go to Edit Dimension Style. And when that opens up, what I want to do is go to Tolerance. And right here it says Basic Dimension, and then pick on the down arrow. And this one says Prefix and Suffix Inside. That's what we currently have. And this one is prefix, suffix, outside. I'm going to pick that and pick Save and Close, and that pushes that 4x outside. Now, this guy over here, there's 2 things I want to do. One is I want to go to Options, and I want the arrows from the inside, like that. And when you do that, it really makes it easy to figure out where the center of this arc is when we see that it originates at that center point right there, rather than just pointing to the edge of it like it was before. And I want to double click on this and go to Precision and Tolerance and choose Basic and pick OK. All right. And let's see, I want this to be 5 times 72. So I'm going to put a 5 in front of that, 5x, and a space. And on my precision, under my angular unit, I want that to be 0 and pick OK. So it's just plain 72 degrees. This would be a 5x right here. I use capital X's. I think some people use lowercase. I think the important thing is that you are consistent with whatever you do. Okay, so we're missing a dimension on here, and what it is, it's the diameter of this bolt pattern. So I'm going to go to Dimension, and I'm going to choose on this bolt pattern right here. And this is a good example of where, you know, these arrowheads should go all the way through and be on either side. So I'm going to right click on that. Actually, I have to press escape first. Right click, go to options. What I want is arrows inside. I want leader from the center, and I want to right click on that and go back to options and turn off single dimension line. So now you can see that, you know, the arrows go both ways, and it really clears up for the person making this, you know, what's going on with that diameter of that bolt pattern. And now that I know where that's located, I might move this up because I don't want these to be too crowded. And I'm going to double click on this because I need to add some information right here. I actually need to put in a plus minus, and I should have a symbol for a plus minus in here someplace. I believe I do. See if I can find it right there. A plus minus 0.5, and it's the same thing over here after this depth. I need a plus minus and a 0.5. That's according to the sketch that I have these tolerances that are a little bit different than what they are everywhere else. I think I would like a space after that, maybe a space after this. Pick OK. All right, and in fact, I can take out this through. I don't need to have that in there, and pick OK. So it's looking a little bit cleaner now. So if I go through and I highlight everything that I've done now, I have just about everything in here. One of the things I'm going to do though is I'm going to add another datum symbol onto this circle just to show you how that's done. So you can pick right on the datum and move out here and pick like that. And we want to make this B. Okay, and pick OK. So when we place a datum identifier on a cylinder, like on the edge, we're saying it's the center axis is what the datum is. And so that's where, you know, all these dimensions, these basic dimensions, the 45 degrees and the R75 are all coming off of that center axis right there. So if I could even extend these center lines in to where they're, you know, almost touching that center axis if I want to, right? I want to make them consistent, whatever I'm doing. All right, so that looks pretty good. I think I have most everything in here, you know, as I'm highlighting as I go. I'll still come back in and do some fine tuning, but one of the things I want to do is place a text box in here. And in this text box, I'm going to put notes, unless otherwise specified. And I'm going to go note number 1 is that the material is mild steel. 2 is that tolerances are plus or minus, I'm going to find a symbol for this, there it is, plus or minus 0.25 UOS, unless otherwise specified up there. So really that's kind of redundant because it says unless otherwise specified. I could actually probably take that one off. But I do have some others that are a little bit different. Like we put those in a minute ago that were 0.50. I don't think I need that period right there, but I need a period here. And interpret drawing per ASME Y14.100, which is the way we interpret views, and ASME Y14.5 M, because this is a metric drawing, dash 2009. So ASME Y14.5 M is the dimensioning standard established by the ASME group. And the last thing I'm going to put on here is isometric scale 1 equals 4. Now I'm going to pick OK, and so that's where that's going to go in. And I'm going to move that kind of down in here, maybe down a little bit farther, because I want those notes to be below the top of my title block. And this is just a rule that I have for the class, but sometimes you go to work for some outfit and they'll have rules like that. Now, the other thing that I want to put in here, though, I'm going to go to Place Views, and I want to put a base view in, and I want to choose the offset flange. Let's see if I can find my offset flange. Let's see. Those would be, where'd I put those? Right here, daily work. So I need my offset flange, IPT. Well, I don't see one in here, so I'm going to just do it the other way. I'll do a projected view, and I'll pick off of this, and I'll go, I think I want to put it in that direction right there. So I'm doing a projected view off of the front view, and I'm going to pick, right click, create. I'm going to double click on that, and I'm going to shade it, and I'm going to make the scale 1 equals 4, and pick OK, and that makes it a lot smaller, and I can place that up in there. And now I could actually come in and I can move my views over a little bit, sort of balance things out a bit if I want to put them on, you know, like that. Or I could even put it over here on this side and move everything else, you know, move this view over and move this view over. Be careful when you move it, though, because if you have GD&T, you might move a dimension away from your GD&T. So there's an option to do all that stuff right there and to have your isometric scale. Now, you'll still need to fill out your title block. And remember that to fill out the title block, you'll want to come over and find your title block in the browser and expand on it, and then double click on field text. And so your scale here is going to be 1 equals 2. That was the scale we put our main views in at. And of course the date, the drafter, that's your name or your initials. The section number is whatever your instructor tells you you need to put in there. And since this is a one-sheet drawing, I would write 1 of, don't use a 0, use an O, 1 of 1, and pick OK. And once I have all that filled out, my drawing's essentially done at this point. Now, I am noticing this distance right here and this distance in here are not equal. So you can move this up a little bit if you want, make that equal, but just remember that you don't want that datum identifier to be in line with that. It needs to be moved up. This guy, though, has to be in line with the diameter 200. And if it's not, it actually changes the interpretation. So if you do that, that's like a -5 type mistake. That's a pretty big mistake. We want to line that guy up exactly with our diameter 200 like that. Okay, so next thing you would do is do a file save as if you haven't already, and give this a name and name it offset flange and save it in your home folder or wherever you're saving it. Then I would just go in and fine tune, and I would make sure you could see all of your center lines and all that sort of stuff. So that's the basics of dimensioning the offset flange and adding all this GD&T for tolerance of position, where the datum is the center axis of a diameter 200 cylinder that you have right here. Good luck.